Chapter 5, Section 4 in the 8th grade textbook is entitled Solving Proportions. When we're talking about proportions, we're really talking about two ratios being set equal to each other, or to what many of you is going to look like just two fractions with an equal sign stuck between them. What they're saying there is that these two ratios are equivalent when they're talking about a proportion. What they're really going to test of your knowledge here in this section is, are they actually equivalent? So is the fraction or the ratio on the left side the same as the fraction or the ratio that's on the right side? And there's lots of different ways to find out if that's true. You can try and make the fractions equivalent by reducing them down to the same thing, or you can, if you want to, come up with a common multiple, preferably the least common multiple, and see if the fractions are the same. Or you can divide the fractions out and see if they are the same thing. And in any case, if you were to get something the same from those two guys, then your answer would be yes, they are in proportion. And if you were to get something different from those two guys, then the answer would be no, they are not in proportion. What this section is going to spend a lot of time talking about, though, is solving proportions with the idea of cross products. Define the products of the numbers on the diagonal when comparing two ratios. In the proportion A over B equals C over D, the cross products are the result of A times D and B times C. Again, the products of numbers on the diagonal when comparing two ratios. In the proportion A over B equals C over D, the cross products are the product or the result of A times D and B times C. So what they're saying here is, to prove that these are a proportion, multiply the numbers you have on each diagonal. If you get the same result, the answer will be yes, they are proportional. And if you get different results, the answer is no, then they are not proportional. So if we look at the A example there, 6/15 equal to 4/10, they do 15 times 4, which is 60, and they do 6 times 10, which is also 60. Again, you were multiplying on the diagonal. And in this case, because the result on each diagonal happens to be 60, the answer here is going to be yes, that the ratios are in proportion. If we were to have ended up with answers that were different, then we would say no, these fractions or ratios are not in proportion. All right, the B example is more of the same, but it's in the context of a word problem. It says a mixture of fuel for a certain small engine should be 4 parts gas to 1 part oil. If you combine 5 quarts of oil with 15 quarts of gas, will the mixture be correct? So they go ahead and they write a couple of ratios there, 4 parts gas to 1 part oil, and 15 quarts gas to 5 quarts oil. Now, one of the things you have to notice is that they said in the first sentence, in that comparison, 4 parts gas to 1 part oil. And then in the second sentence for that comparison, they started off with the oil number and then gave gas. You have to make a decision. If you want to write it like the first one, 4 parts gas to 1 part oil, you have to write the second comparison the same way, with the gas number first and the oil number second. If you want to write it like the second one, you've got to write the oil number first and then the gas number second. It doesn't matter which one you do, but you have to pick one and stick with it. So as you can see, in both of these ratios, the gas number is first and the oil number is second. All right, so now in essence, what they're asking me is, are these guys proportional? Well, the way to check that is to, again, multiply the diagonals. So on the one diagonal, I have 4 times 5, which is 20. On the other diagonal, I have 15 times 1, which is 15. Since I got different numbers here, the answer is going to be no, that these guys are not proportional, or in other words, the mixture is not going to end up being correct because the numbers are out of proportion. let's go ahead and take a look at number 2. The ratio of boys to girls in a soccer league is 4 to 5. If there are 52 boys in the league, how many girls are there? So the first sentence tells me that the ratio of boys to girls is 4 to 5, which means for every 4 boys, there are 5 girls. The reason I know that is because the sentence says boys to girls, and then it says 4 to 5. That has to be written in the same order. So they are saying boys first and then girls, and then they say 4 to 5. The 4 number has to represent boys, and the 5 number has to represent the girls. Now they want to know, if I bubble this up to represent 52 boys, how many girls are there? So look at the second line of work there. They start off with 4 over 5. Again, 4 for boys, 5 for girls. And then they write another fraction there that has 52 on the top and X on the bottom. 52 on the top because 52 represents the number of boys, just like the 4 did. Again, like we talked about in the word problem a minute ago, because I wrote that boys number on the top, anything that represents boys now is going to have to also go on the top. And that bottom there, X, is there because I'm supposed to figure out how many girls there are. And remember, girls' numbers go on the bottom. Now you're saying, well, how does this help me? This isn't really like the last questions where I'm trying to figure out if the results are the same. Well, it is a lot like the last question, actually. All right? To prove they are proportional, the diagonals have to make the same thing. So when I do 5 times 52 on the one diagonal, I have to make 260. All right? That means on the other diagonal, that also has to be 260. So I'm saying 4 times what number is 260? And as you can see, that's set up in solving in equation form. They take 260 and chop out the 4, and they get 65. 4 times 65 gives me 260, just like 5 times 52 gives me 260. Since the results are the same, that's how we would know they're in proportion. That's how we know we solved it correctly. That's how we know our missing answer there, where X is, represents the number 65. There are 65 girls in the league. All right, number 3. A banana slug travels 4.5 inches in 120 minutes. At this rate of speed, how long would it take the slug to travel 12 inches? So this is more of what we just did, not just saying that the left and the right sides are equal or the ratios are in proportion, but actually trying to find one of the numbers. So they said in the first sentence that the slug travels 4.5 inches in 120 minutes. So they wrote 4.5 inches over 120 minutes, the distance being compared to the time. Now they want us to write another fraction that compares distance and time. What they gave us is 12 inches, which is what's going to go up here. But down here where it says time, we don't know. So all we can write there is t, which is time. And now I'm going to solve by cross multiplying. We know that this diagonal, 12 times 120, gives me 1440. So this other diagonal has to have a product that's also equal to 1440. So they're saying 4.5 times t equals 1440. Solve the equation. Well, by solving this one by doing the opposite dividing, as we always do when we solve an equation, I do 1440 divided by 4.5, and I end up with 320. T equals 320. My mystery spot is 320, or in other words, it would take the banana slug 320 minutes, or converted 5 hours and 20 minutes to travel that 12 inches. All right, let's go ahead and take a look at number 4. It says Nate has 225 envelopes to prepare for mailing. He takes 30 minutes to prepare 45 envelopes. If he continues at the same rate, how many more minutes will happen until he completes the job? All right, so they're going to go ahead and set themselves up a ratio here that compares 30 to 45. It's 30 minutes to do 45 envelopes. They want to know about preparing 225 envelopes. So when we look at the fraction over here on the right, notice since the envelope number is in the bottom, over here it's also in the bottom, and the top is my mystery x, because that's what I'm going to find. So now we can solve this guy by cross multiplying. On the diagonal of 30 and 225, the result is 6750. So we know this other diagonal, 45 times x, has to be the same as 6750. Well, as you can see, they're showing this by solving the equation, and by solving this equation to get x by itself, chopping out 45, and they get 150. So it's going to take him 150 minutes to do 225 envelopes. Now, that doesn't really answer the question, though, because the question is how many more minutes will elapse for him to complete the job. He's already spent 30 minutes doing 45 of the envelopes. So what they do to actually solve the question here now is subtract off 30 minutes that he's already spent to find out that it's going to take him another 120 minutes to finish off the rest of the envelopes. All right, so let's go ahead and take a look at the check it out examples here at the bottom of the page. As you can see, there are more than a few. Number one, we're supposed to tell whether the ratios are proportional. And in this case,